Good afternoon, everybody. So today I'll be talking about the pathways to circular economy for food waste. This talk is based on a case study that we did for the City of Playford, where we were looking for options that would have the biggest potential to increase diversion rates and how these options might enable circular economy. I would like to take this opportunity to acknowledge my co-authors on this project, Karina Saras from the City of Playford, Charlotte Wang, who is going to speak this afternoon from MRA Consulting, and my colleagues, Dr. Nick Florin and Professor Damian Jurko from the Institute for Sustainable Futures at UTS. So what is circular economy? We're starting to hear this term everywhere. It has been used in the news by our politicians, ministers. Circular economy is a proposed alternative to the linear economy of take, make, use, dispose approach, which we have become accustomed to. It can be defined as a regenerative system in which resources, input and waste, emission and energy leakage are minimized by slowing, closing, and narrowing material and energy loops. So if we look for food, this can be achieved through sustainable growth and production, minimal transport, localized consumption, and utilization of the food waste to extract nutrients and energy. So just to put into perspective what impact food waste has. So worldwide, we waste a third of 4 billion tons of food that we produce, which is approximately 1 trillion Australian dollars. And if only 1/4 of this wasted food could be saved, we would feed 870 million people. So if we look at the greenhouse gas emissions, 8% of greenhouse gas emissions are emitted from food waste. This is 4.4 million tons of CO2, which is equivalent if we took 1 in 4 cars in the road. Also, wasting food, we waste water. And so when you throw away 1 burger, you have wasted as much water as if you had a shower for 1.5 hours. So Australian contribution in wasting food is 20 billion per year. Literally, as everyone has probably heard this in War on Waste documentary, 1 in 5 shopping bags is thrown in a bin on average in household. That is 4 million tons of food is destined to landfill. So I would like to show you this artwork. This has been shown at the Sydney Design Festival by Anna Bellotti. So she created a series of artworks on textile when she was trying to show how striking food waste is. And in this photo is, if you look at the circles, the big circles represent people, so it's 20 people, and the little dots represent a kilo of waste, that people, a kilo of waste. And what this picture shows is that each person wastes 200 kilos on average in Australia. And I guess, I thought it was quite a nice way to see what this really is. So food actually in nature has a very, a normal round life cycle. So it grows, then it's either used or reproduced and consumed by animals and humans, or humans consume animals, and then it's disposed and would go back into the soil, and that would be the natural cycle. But what we have managed to do, we have managed to break that cycle and make it linear. So instead of using the food waste, we have synthesized fertilizers, which we feed into the system to grow food. And we produce it, distribute it, and then we waste it. We throw it to the landfill as opposed to return it back to nature. And along this path, there is, in every single step, leakage and waste. So food waste is a problem, clearly. So if, from a council perspective, a third of general waste is food waste on average, which proves to be a significant burden in landfill levies. And the way councils are trying to address this problem is they would like to increase the diversion rates from landfill. They would like to offer services that will deliver this increase. But the question I'd like to ask is, will these decisions align with circular economy parameters? Is this enough? If we can put what would look like a sustainable food life cycle, so and that includes some parameters for circular economy, the generated food waste and both the organic materials and the biogas that are recovered would be fed back into the system and would follow like a loop, a closed cycle. Can we achieve that with sustainable management of food? So this is like if borrowed from waste hierarchy, but adopted for management of food. And from the top to the bottom, we go from the most preferred to the least preferred option. So the first option, or the most desirable option, would be that we would reduce the surplus generated food. That clearly would have environmental benefits because we would reduce pollution due to fertilizer, pesticides. We would save energy because growing, preparing, transporting the food. We would reduce methane emissions from landfill disposal. We would save water. What can councils do on this level? They could provide workshops, information programs for food avoidance, encourage people to prepare grocery lists and keep inventory of supplies, using leftovers and cooking with food scraps, buying less and produce less, minimize packaging. These are the initiatives that council can help people to do. I would also like to say that in developed world, most of the food is wasted at the end, while in developing countries, they waste at the production level, but they don't waste at the end. While in our case, from cosmetic values and all other reasons that gets wasted. We could also feed hungry people with the leftover food. This applies for developed countries as well, not just undeveloped. In Australia, 20% of purchased food is discarded, as I mentioned before, of which 33% is fresh food. And again, what could councils do? They could facilitate services such as food banks and provide opportunities for food donations and provide grants to enable innovation to come up with new solutions. And the next way to try to not dispose of food would be to feed food scraps to animals. Now, in regional councils, that is, so you have a connection with the agriculture and you get it back to the industry. While in cities, that could be also to facilitate community gardens, which would include chickens, or allow them to be in an urban environment. Now, so from this point on, I'll be looking at the collection of the curbside waste and what options are. As a case study, we're using City of Playford, so it's a little council in the north of Adelaide, and this is just using it as an example to go through and show the way of thinking. So for their problem was that they had low diversion rates, and they wanted to increase the diversion rates, and they were looking for the options, how to improve that. And one of the clear results straight away was that they had still an enormous amount of food waste in their red bin. So the methodology of the study was we first did a literature review, stakeholder interviews, and then we derived the options and provided cost and benefit analysis for the derived options. So they had 34% of food waste in their red bin. So what could you do with that? You could either collect separately, food organics, garden organics, or combine as further. And one of the things or barriers that we need to look at was that can enhance the participation in FOGO was found to be collection frequency. So is the diversion rate the best indicator to base the decision on which option to use in curbside waste collection? And which impact might this decision have on the subsequent steps in the food waste management cycle? And how does the selected option impact the opportunities for the circular economy? So from the technologies downstream, the preferred one in hierarchy is anaerobic digestion. And the advantages it has, apart from enabling the circular economy, it captures both nutrients and biogas. It's scalable, adaptable. However, in Australia, it hasn't been adopted much. It's only an emerging technology and been applied with very, very limited success. The next step would be looking at composting, which also enables circular economy parameters. And however, in this process, the nutrients are collected and the gas is not. It is also scalable, as you can have it at home, you can have communal or industrial level. And the main barriers are that it still emits gases, methane and N2O. And with that, we lose energy, we do not collect energy, and we face issues of contamination. And the next step along the line is incineration, where the energy can also be recovered through incineration. And the disadvantages are that, so for example, if you might say, what is the difference between incineration and collecting gas from the landfill? And it does actually depend what type of food waste you have if you did the studies and compared. So the carbon content is a big determination in what is a better approach to do. So if you had your lettuce, you would better leave it in the landfill to rotten, while if you had bread, you would be better off burning it. And the last, and really the least desirable option, obviously, is landfill. And what happens in landfill? So food breaks down into methane and CO2. And we worry about methane because it's 25 times more potent greenhouse gas. And in Australia, about 60% of large landfills collect gases. However, the efficiency is limited because you can only collect about 50% of methane that is captured in a landfill in its lifetime. And also, the concentration of methane in that captured gas is only 40 to 60%. And most of the time, it's just flared, which means they just burn it to CO2 and is not always used for electricity. So to look at the difference between, to compare the different food waste management technologies, we looked at how do they compare from economical, energy, or material collection and environmental point of view, and we applied the multi-criteria benefit score on it. And as you can see, clearly landfill is the worst, except from some economical advantage. And landfill with methane scores slightly better because it does collect energy and reduces the emission of the greenhouse gases. Anaerobic digestion scores better than the compost purely because of the energy not being able to be collected at the compost. However, it's a more expensive technology and scores lower on economical point of view. And incineration is obviously not good for economical point of view and materials. So when we talk about the parameters indicating a circular economy, how do we choose which is the best option for food waste management and which parameter is the best indicator in supporting a transition? We could use diversion rates. We could use zero waste index, which was developed to include the amount of virgin materials, energy, water, and greenhouse gas emissions that are substituted by resources. And also looking at the selection of option and effect on the downstream waste management technology. So if we look the way we collect waste and where can it be sent or what can be done with it, we can see that anaerobic digestion seems to be the most flexible in your method of collection. So the options that provided the highest diversion rates for the City of Playford case study were that FOGO with compostable bags. The change of frequency of collection service would provide even higher diversion rates. However, in South Australia, that is not feasible due to the legislative constraints for Metropolitan Adelaide, which they have to collect waste weekly. And anaerobic digesters have issues with compostable bag, as well as frequency of collection could not be compatible because of the stream being supplied to. So the non-technical institutional, regulatory, and cultural barriers and process and parameters are applicable to metropolitan councils Australia-wide. However, the non-technical barriers limiting implementation would be more specific to individual councils. So how could the future look like? So just to build up on the previous picture on circular economy, we could also in future extract, let's say, cellulose out of waste and make new products, textiles, or maybe new type of films, which would replace plastic films, and develop a whole process with recycling and collection that could be closed in a loop. So in conclusion, food life cycle, the curb waste collection options followed by food waste management technologies have been explored using the City of Playford processes as a case study. Options for circular economy have been analyzed, taking into account the economics, energy, carbon footprint data from literature as well, adhering to the food waste reuse hierarchy. Increasing diversion rates by removing food waste from landfill is aligned with the transition to a circular economy, and diversion rate alone does not provide sufficient insight to evaluate different options that the council might implement for a more circular economy, which are limited even further by non-technical issues. And a stronger focus on non-technical barriers is likely important for supporting the transition to a circular economy. Thank you.